Hi guys, I'm back with my lectures. Okay.
Hi guys, I'm back with my lectures and this is Mr. Joseph, your chemistry teacher. Now today's lecture is a continuation of our previous lecture on solutions and concentration. Now I want to look at calculating solution concentration by titration. We say titration is often used to find the exact concentration of what? Of a solution. In our last class we talked about solution and concentration. We talked about standard solution, which is a solution with a known what? With a known concentration. So today's class we'll be looking at calculation on what? Concentration of a solution by titration. How you can calculate solution concentration by what? Titration. So we'll be looking at more advanced questions. So please, I want us to listen attentively so you can get the best out of today's class. Because in acid-base titration, in redox titration, and any other type of titration, you'll be asked to solve questions. You'll be asked to calculate concentration. You'll be asked to calculate the volume. You'll be asked to calculate the mass. You'll be asked to calculate the percentage by mass. You'll be asked to calculate the molar mass. So we're going to look at different questions that will help us to what? To handle what? Problems involving what? Calculating solution concentration by what? By titration. So please, I want us to listen attentively. So this is a typical example. Vinegar is a solution of ethanoic acid, 10.0 cn cube of a certain brand of vinegar, needed 55 cn cube of 0.2 mole per dnq sodium hydroxide solution to neutralize the ethanoic acid in it. So this is the equation for the reaction. We are given the equation, which is ethanoic acid, which is the acid react with sodium hydroxide as the base to form sodium ethanoate, which is salt and what? And water. So you're asked to calculate the concentration of ethanoic acid in the vinegar in mole per what? dm cube. So you have to calculate the concentration. Now from our previous, lecture, we look at solutions and concentration, and I gave you the formulas to use when you're asked to calculate concentrations, number of mole, and I gave you the formula that relates molar concentration to mass concentration, number of moles to concentration in mole per dm cube, number of moles to mass, and number of moles to what? Molar mass. So in this question, we are given volume of the acid, which is the vinegar. The volume here is what? Volume of the acid, Va, is equal to 10.0 what? Cm cube. Needed 55 cm cube of the sodium hydroxide, which is the base. Volume of the base is equal to what? 55.0 cm cube. Concentration of the base is equal to what? 0.200 what? Mole per dn cube. dn cube. Sodium hydroxide, which is the base, to neutralize the ethanoic acid. So we're asked to calculate the concentration of ethanoic acid in the vinegar in mole per what? In mole per dn cube. So the first thing we're going to do, we're going to calculate the number of mole of the base. Number of mole of the base is equal to what? Concentration times volume over what? Over 1000. We divide by 1000 because the volume is in cm cube. So what's the concentration of sodium hydroxide, which is the base? The concentration is 0.200 times the volume is what? 55.0 what? 0. 55.0 cm cube. Divided by what? 1000. So I'm to use my calculator now, which is 0.200 times 55.0 divided by 1000. So you have 0.011 what? Moles. That is the number of mole of the base. Now we'll now go to back to the equation. From the equation, 1 mole of ethanoic acid react with what? 1 mole of sodium hydroxide. So if 1 mole of ethanoic acid, 1 mole of ethanoic acid reacts with 1 mole of sodium hydroxide, which is the base. Therefore, 0.011 moles of sodium hydroxide will react with what mole of the acid. So you cross multiply. When you cross multiply, I have to erase the top, so I'll have space to solve. So you will have X, which is the number of mole of the acid, will now be equal to what? 0. What? 011 what? Moles of what? Ethanoic acid, CH3, COOH. So the number of mole of ethanoic acid equal to 0.11 moles. So you have to calculate the concentration of ethanoic acid. So I'll bring out our formula. Number of moles is equal to concentration times volume over what? Over 1000. So number of mole of the acid is equal to what? 0.011 is equal to the concentration. That's what we are looking for, concentration of the acid, times the volume. The volume is what? 10.0 divided by what? 1000. So I have to erase this so that I'll have enough space to solve. So what you do, you cross multiply. So you now have what? Concentration times 10.0 is equal to 0.011 times 1000. So 10C is equal to 0.011 times 1000. So to get a concentration, divide both sides by 10, divide both sides by 10. So when you cancel out, the concentration now be equal to what? 0.011 times 1000 divided by 10. So you have what? 1.1 what? Mole per what? dm cube. So that is the concentration of what? Ethanoic acid. 1.1 mole per dm cube of what? Ethanoic acid. So as you can see, it's as simple as what? As A, B, C. All you just have to do is just to apply the formula and make, the quantity you have to calculate the subject of the formula. So it's as simple as ABC. So now let's go to more advanced questions. More advanced questions based on what? Calculating solution concentration by what? By titration. So we'll move back to more advanced questions. So please, I want us to listen attentively. It's as simple as what? ABC. Now looking at the question before us, N2O4 is a poisonous gas. It can be disposed of safely by reaction with sodium hydroxide. Sodium hydroxide is a base, so it will neutralize what the poisonous gas. So they are now asked what is the minimum volume of 0.5 mole per dm³ sodium hydroxide needed to dispose of 0.02 mole of what? Of N2O4. So now let's see. The first thing you have to calculate the volume. What is the minimum volume of sodium hydroxide? Now, if you look at the equation, you go straight to the equation. If you look at the equation, we'll have 2 moles of what? N2O4 reacts with, we have 1 mole of N2O4 reacts with 2 moles of sodium hydroxide. 1 mole of N2O4 reacts with 2 moles of sodium hydroxide. So from the equation we are given what? From the equation we are given 0.02 mole of N2O4. So if 1 mole of what? 1 mole of N2O4 reacts with 2 moles of sodium hydroxide, therefore 0.02 react with what? Moles of sodium hydroxide. So what you do, you cross multiply. So we now have X now will be equal to what? 0.02 times 2 over 1. So we'll have, let me use my calculator, 0.02 times 2 is equal to 0.04 moles of what? sodium hydroxide. So we'll have 0.04 moles of sodium hydroxide. We are now asked what is the minimum volume of 0.5 moles sodium hydroxide needed to dispose of what? 0.02 mole of N2O4. So applying our formula, number of mole is equal to what? Concentration times volume over what? 1000. So we have to calculate the minimum volume of 0.5 mole sodium hydroxide needed to dispose of what? 0.02 mole of N2O4. 0.02 mole of N2O4 will require what? 0.04 moles of what? Sodium hydroxide. So the number of moles of sodium hydroxide here is what? Equal to what? 0.04 is equal to the concentration of sodium hydroxide is 0.5 multiplied by the volume. That's what we are looking for, the minimum volume that's needed to dispose of 0.02 mole, which is equivalent to 0.04 moles of sodium hydroxide. So 0.04 is equal to 0.5, which is the concentration times the volume, which is V. That is the value we're looking for over what? Over 1000. So what we need to do, we'll cross multiply. So let me erase the top so I'll have space to solve. So when you cross multiply, you now have what? I have 0.04 times 1000 will be equal to what? 0.5 V, which is the volume, the minimum volume. So to calculate the volume now will be equal to 0.04 times 1000 divided by what? 0.5, which will now be equal to times 1000 divided by 0.5 to 80, which is equal to what? 80 what? cm cube. So the answer is what? 80. So the minimum volume of 0.5 moles of sodium hydroxide needed to dispose 0.02 mole of N2O4 is equal to what? 80 what? 80 cm cube. So the answer is what? D. It's as simple as what? A, B, C. All you just need to apply the formula, get the variables, get the quantities that that you are given, then you can calculate what you're asked to calculate. So it's as simple as what? As simple as A, B, C. The first step, understand the questions. The second step is what? Take note of the values you are given. Then the last step, just apply the formula and solve. So we're still going to solve more questions. Okay, this is another example, more advanced. A household bleach contains sodium chloride 1, NaClO as its active ingredient. The concentration of what? Sodium oxychlorate in the bleach, which is NaClO, can be determined by reacting a known amount with aqueous sodium hydroxide. So just like a kind of normal titration reaction. So what happened is that what? When 25.0 cm cube of bleach is treated with an excess of aqueous hydrogen peroxide, 0.0350 mole of oxygen gas is given off. You are now asked what is the concentration of what? Sodium oxychlorate in the bleach. That is what's the concentration of NaClO in the bleach. So the first step is to understand the question. A household bleach contains sodium chlorate 1, which is NaClO, as its active ingredient. So the concentration of sodium chlorate 1 in the bleach can be determined by reacting a known amount with aqueous sodium hydroxide. So when 25 cm cube of bleach is treated with an excess of aqueous hydrogen peroxide, 0.0350 mole of oxygen gas is given off. What is the concentration of sodium chlorate 1? So the first step is, now let's look at the equation. Now from the equation, 1 mole of what? Sodium chlorate 1 react with 1 mole of hydrogen peroxide to produce what? To give off 1 mole of what? Oxygen. So when 1 mole of what? When 1 mole of sodium chlorate 1 reacts with hydrogen peroxide, what happened? 1 mole of oxygen was released from the equation. That means 1 mole of oxygen, when 1 mole of oxygen is released, 1 mole of sodium chlorate 1 has what? Reacted. So that means 0.0350 moles of oxygen will require what? What mole of sodium oxychlorate 1? So you cross multiply. I think it will require the same mole. So X now will be equal to what? 0. What? 0.350 moles of what? Sodium chlorate what? Chlorate 1. So we've now gotten the number of moles of sodium oxychlorate 1. So 1 mole of sodium oxychlorate 1 is equal to 1 mole of oxygen. So 0.0350 moles of oxygen is equivalent to what? 1 mole of what? Sodium chlorate what? Sodium chlorate 1. Now, we now took 25 cm cube of the bleach, then treat with an excess of hydrogen peroxide. So hydrogen peroxide is in excess, so we don't need to bother ourselves with that. Then now ask what is the concentration of what? Sodium chlorate 1. So I think I need to erase this, so I'll have enough space to solve our question. So using our formula, number of moles is equal to concentration times volume over what? 1000. So the number of mole of sodium oxychlorate 1 is equal to what? 0.0350. So this is the number of mole of sodium oxychlorate 1 that reacts with what? Excess of what? Sodium chlorate 1. They react with an excess of hydrogen peroxide, I mean to say. So 0.0350 is equal to the concentration, that's what we're looking for, times the volume, which is what? 25 cm cube. The first thing of the bleach, sodium chlorate 1 is the active ingredient in the bleach. So that's what will react with what? The hydrogen peroxide. So please take note of that. Divided by what? 1000. So when you cross multiply, you now have what? 25C is equal to 0.0350 times what? 1000 times 1000. So what happened? To calculate the concentration, 25C so 25C will be equal to what? 0.0350 times what? 1000. So therefore, concentration now will be equal to what? 0.0350 times 1000 divided by what? 25. So let me erase this so that I will have enough space. So we have to calculate the concentration now of sodium chlorate 1 in the bleach. Concentration now will be equal to, I have to use my calculator, 0.0350 times 1000 divided by 25. So you now have what? 1.4 mole per what? dm cube of what? NaClO, which is sodium chlorate 1. So the answer to this question is what? D, which is 1.40 mole per what? Mole per dm cube. So it's as simple as what? As ABC. All you just need to do is to understand the question, then you take note of the values you are given, then you apply the formula. So it's as simple as ABC. So I expect you to solve as many questions as possible, and feel free to reach out to me if you encounter any difficulty in the process of trying to solve any question. So we'll be ending our lectures for today, and just it's as simple as ABC. Just follow the step, understand the question, apply the formula correctly, and I believe you'll get the right answer. So I'm Mr. Joseph, your chemistry teacher. Please subscribe to my YouTube channel. Feel free to reach out to me. Go to the comment section and give your feedback. And we'll meet in our next lecture. Thank you very much. I'm Mr. Joseph, your chemistry teacher.